So let's pick up with the problem that we left off on in topic 1.5, and that's this question of what happens when we use the approach of direct substitution to evaluate a limit, but we get what we defined as the indeterminate form. And so the problem that we left off with was the limit as x approaches 2 of x squared plus x minus 6 divided by x squared minus 7x plus 10. And as I mentioned earlier, at the very end of topic 1.5, we simply tried to use substitution, and we found that substituting in x equals 2 gave us 0 divided by 0, which again we define as the indeterminate form. And it's called the indeterminate form because you can't make a statement off of it yet. It's easy to see, oh, 0 divided by 0, that must mean it's undefined or the limit doesn't exist. The limit actually does exist. What it means is that the function is undefined at x equals 2. But the limit does exist, and that's what we're going to find here in this lesson. And it's not 0. It's not an undefined thing because we're dividing by 0. It's actually a finite value. So when we get an indeterminate form of 0 divided by 0 when evaluating a limit, directly, like we tried to do, because that's what we learned in topic 1.5, that we can evaluate these limits directly, then this means we're going to have to go grab another tool out of our toolbox. And so we must use algebraic techniques either to simplify or just rewrite a function. And my guess is if you're to a calculus class that you can look at this particular function and see what we can do to both the numerator and the denominator and see if something works out for us. And in fact, that's what we'll do here in the next video. So if we get 0 divided by 0, that means we need to try something else. And today it's going to be algebraic techniques. If direct substitution gives us the form of a divided by 0, where a is not equal to 0. So if I get some value divided by 0, that's not 0 divided by 0. 0 divided by 0 is the indeterminate form, but any other number divided by 0 is going to tell us that the function has a vertical asymptote at that value, and therefore, if we think back to what we've looked at with asymptotic or unbounded behavior, therefore we're going to be able to say the limit does not exist. And we'll explore that more later on the unit. So what we need to know now, if we get 0 divided by 0, which is this indeterminate form, then we need to try something algebraic. If we get a divided by 0, which is any number not 0 divided by 0, that tells us we have a vertical asymptote.